My name is Joe Heineman, and today I'll be exploring how engineering ethics impacts the design of modern autonomous vehicles and how these challenges can mirror past failures like the Ford Pinto case. The first, I want to discuss virtue ethics in engineering. Defined as the development of moral character and virtues, guiding engineers to act responsibly in complex professional situations. So it emphasizes the importance of intellectual, civic, and moral virtues, and this is important in engineering. So the NSPE Code of Ethics is a commonly used ethical framework by engineers. It's adopted by the National Society of Professional Engineers. And this ethical framework guides engineers to act with integrity, responsibility, and humility. So these are important virtues to apply to engineering as they guide engineers on how to deal with complex ethical dilemmas and how to apply ethics to engineering and to their work. Okay, so first I'm going to discuss autonomous vehicles. So what is an autonomous vehicle? It is any vehicles that are capable of operating with minimal human input. They're designed to be a safer alternative to a traditional vehicle, as well as to increase the flow of traffic and the overall efficiency on the roads. So, some new technology in the industry. A popular example of autonomous vehicles is Tesla. So, Tesla began designing self-driving systems in 2013, and in 2014 they released the first autopilot car that contained autopilot capabilities. So nowadays Tesla incorporates an FSD system. It's a full self-driving system. This system is available through a monthly subscription service to Tesla owners. Now, this system, it still requires drivers to remain aware. So they need to keep their hands on the steering wheel while it's in use. Um, and they need to remain aware just as if they were driving any normal vehicle. So this system, it's still not a fully autonomous vehicle, but it is far more advanced than the technology that they started with back in 2013. So they've faced backlash for system malfunctions and system failures of their system. One example is a Tesla failed to stop at a lowered railroad crossing that was in Texas during April of this year. So this accident was only narrowly avoided by the driver having to accelerate, and they had to basically floor it to avoid contact with the train. So this was a very dangerous situation for the driver, and it was a very serious system failure by Tesla. Um, another instance is their robo-taxi service. So this service is active in Austin and San Francisco. There have been 14 recorded crashes since their debut in 2025. This is not an insignificant figure, considering there's a small fleet of these robo taxis currently in service. So the 14 crash statistic might seem small at first, but it's fairly significant. Um, so the technology continues to advance each year, and nowadays a variety of other manufacturers are also developing AVs. So companies like Waymo, Zoox, and a variety of other established automakers are now designing their own AV systems. So companies like BMW and Volkswagen are also designing their own self-driving systems. So the autonomous vehicles are becoming more popular. Other automakers are now getting involved. So it is an up and coming technology. So we can imagine a future for self-driving vehicles where they become more commonplace, or possibly even replace a traditional automobile entirely. Now, what would be the effects of the globalization of autonomous vehicles? So theoretically, if the tech continues linear progression each year, and they're implemented on a global scale, you could expect to see a large decrease in fatal car accidents, which fatal car accidents are responsible for over 1 million deaths annually. So this is a very appealing feature of an autonomous vehicle. Current models of autonomous systems are already decreasing fatal crashes per mile involving another vehicle by 98%. And this is from a study done this year at World Metrics, by World Metrics. Additionally, we'd see some environmental benefits from the mass introduction of autonomous vehicles onto the road. You would see a smoother acceleration and braking pattern when you have a very large, or if all vehicles are replaced by autonomous vehicles, they communicate with each other and they all follow a similar acceleration and braking, and this is going to reduce the fuel consumption and emission rates. Another feature about that is it's going to reduce the wear and tear on some of the replaceable vehicle components like tires and brake pads, oil filters. Like these the waste products from vehicles is going to decrease, and it's going to help the environment by not producing as much waste from vehicles. So, some ethical considerations. What are the ethical implications of using this technology? Well, so you have the removal of autonomy. Right? You no longer have full control over your vehicle or your personal safety. You're putting all your faith in this system to make the safe decisions for you on the road. So while theoretically it is safer statistically, at the same time you are putting your faith in the self-driving system rather than taking the precautions yourself to be safe on the road. So fatal accidents will be minimized as opposed to a traditional vehicle, but they wouldn't be removed entirely. And now, in these fatal accidents, or in these accidents that result in serious injury, who would be at fault? Or would you be held responsible for a failure of your autonomous vehicle systems if, say, maybe you didn't keep up on regular maintenance checks or a system update, or rather would the engineer or programmer be held responsible for the system failures instead? So the responsibility or the culpability is kind of in a gray area regarding these systems. Another issue is the ability of the system to make ethical decisions in an emergency situation. So how would an autonomous vehicle make a decision in, say, a trolley type scenario where it had to choose between the lesser of two evils? Could the vehicle decide between crashing into a wall or running into a pedestrian if it's in a situation where it can't stop in time? So these are moral dilemmas, and they require split-second decisions. Is it possible to program ethics-based rationale into an autonomous vehicle? There's several other issues like job displacement for rideshare drivers, bus drivers, or taxi drivers as well. So assumed risk. So you are accepting some risk and assuming some risk by agreeing to use this technology. Now, what number of potential injuries or deaths as a result of system failures would be acceptable for these vehicles and for the manufacturers of these vehicles? Now, certain incidents would have moral gray areas. If someone is, say, jaywalking, crossing at an unauthorized crossing point, is struck by an autonomous vehicle, the manufacturer could claim that the system is not designed to stop at unauthorized crossing points, and that it's the pedestrian who is at fault. So this scenario could be avoided by a manually controlled vehicle, a human-controlled vehicle, through the awareness and the split-second decision-making of a human being rather than a autonomous system. So is it okay for companies to impose this risk on people who are not explicitly consenting to interacting with these systems? The passenger of these vehicles also assume a risk by trusting the system to keep them safe and putting their faith in the self-driving system rather than themselves. Are they fully aware of the risks they are assuming, and do they fully understand them? And should the companies be held responsible for the system failures? The Ford Pinto case. So in the 70s, Ford discovered a flaw in their design of the Pinto, which made the fuel tank susceptible to rupture during rear end accidents. So if the Pinto was rear-ended, it had the potential to rupture the fuel tank, which would cause fires and sometimes explosions. So this introduced an ethical dilemma. Either Ford fixed the issues before release, which would cost them around $11 per car, or they pay the legal payouts from these incidents where the fuel tank ruptures, and they're prosecuted for it. So Ford opted to not immediately fix the issue and instead pay the expected legal fees, which was projected to be significantly less costly. This is an example of cost-benefit analysis overriding the need for Ford to uphold public safety through their products. Now, Ford eventually did fix the issue, but it was only after intense public backlash. Again, this backlash forced the company to remedy their mistake, not because of any professional or ethical obligation to public safety, but rather that a significant loss of public trust would negatively impact their sales. Acceptable risk. So, what risk of injury or death is acceptable? In the Ford Pinto dilemma, Ford determines that the cost of fixing their design flaw is more than the cost of paying their expected legal payouts regarding the issue. Now, this cannot be the only consideration in this situation. Now, from the NSP Code of Ethics, engineers must, in the fulfillment of their professional duties, hold paramount the safety, health, and welfare of the public. Knowingly accepting and introducing a significant safety risk ignores the obligation of engineers to protect the general health of the public. By placing more value on saving their company money, Ford failed in their professional and ethical obligations to protect the public. So the implications on autonomous vehicles. This is a hypothetical. History tends to repeat itself. So consider this hypothetical situation. A self-driving system development engineer discovers a major flaw where the system malfunctions. The vehicle fails to yield to oncoming traffic during testing around 30% of the time. The system is set to launch in 2 weeks. Reprogramming the system and delaying the release is costly. Your fellow engineers argue that the figure is low enough to meet safety standards, and that other vehicles will be able to react to this behavior, encouraging an on-schedule release. What do you do? So this hypothetical situation contains the same issue of acceptable risk. Risk can never be fully removed, but minimizing it to the best of your ability is a professional and ethical obligation as an engineer. In the Ford Pinto case, a product with a known design flaw is released to the public. By doing this, Ford is failing to uphold professional standards and the integrity of the engineering profession. Risk must be mitigated as much as possible, and the safety of the public must always take precedent over the cost of doing so. As an engineer, you are first and foremost obligated to uphold public safety and health. Your professional obligations to make and save your company money should never take priority. So what can we take away from this presentation, from this comparison? Engineering failures are often not technical, they are ethical. Ford made a decision that public health and safety is worth less than fixing their design flaw. Autonomous vehicles present similar ethical issues. What level of risk is acceptable? Who is responsible? And how much is a human life worth? Engineers are not simply problem solvers. They must constantly be applying ethical reasoning into their decision making and always prioritize the safety and well-being of the public over convenience. Here are some of the sources I used to make this presentation. All right, that concludes my presentation. Thank you for listening.